So let us talk about measure of difference between data measure of difference or variability. So when you have data collection, of course you're interested in finding the center or typical value or balancing point of your data. At the same time, you want to know how your data spread out in that collection. What is the variability in the collection? So in this case, we have different measures. The first one, which is very easy to calculate, is called the range. Range of your collection is maximum value minus the minimum value. So it only takes on the first value and the last value in your collection, and you're not working with the middle values. Next, we can find standard deviation. Which counts every member in your collection and actually find the average distance between each data and the mean. Very well, so range is easy, maximum minus minimum. To find standard deviation, we're going to use a calculator. One other important thing is 5-number summary. 5-number summary, those numbers are actually help you to divide your data collection into different portions and understand the behavior and pattern in your collection. So what you're going to do, you're going to find the minimum value, you're going to find the maximum value, then you're going to find the median of the collection, the middle number. So far we have minimum, maximum, then we have the median. After you find the median of the collection, you're going to find the median of the data on the left-hand side. Also, you need to find a median of the data on the right-hand side. We actually have names for these numbers. The median of the first half of the collection is called the first quartile, Q1, or the first quartile. The median for the second part of your collection is called the third quartile. And as you guessed, the median, you can leave it as median or you can call it the second quartile. 5-number summary to analyze the data. Minimum, first quartile, median, third quartile, and the maximum value. Okay, let us go over one example. So here we have an example of typical monthly temperatures for San Luis and San Francisco. These data collection are listed here. Our goal is to find the range and also the 5-number summary for these collections. Well, first let's take a look at the dot plots to see the behavior or to find any pattern in our collection. As you can see, San Luis temperatures are very varied. There are a lot of differences between these dots, which are actually these numbers here. 29.9, 33.9, 45.1, 56.7, 66.1, 75.4, 79.8, 77.6, 70.2, 58.4, 46.2, 33.9. However, for San Francisco temperatures, as you can see, the data are very clustered. They are very close to each other. Let's take a look at the numbers, the temperatures in San Francisco. We have 51.1, we have 54.4, we have 54.9, we have 56.0, or just 56, 56.6, 58.4, 59.1, 60.1, 62.3, 62, and 57.2, and 51.7. Okay, as you can see, these numbers are very close to each other. And when you're looking at the dot plots, you don't see that much of difference between them. So which one is more varied? Visually, you can say that, hey, I see more variability in the first collection than the second collection. Well, let us find the range of the collection. So in this example, we have temperatures of San Luis and San Francisco. So San Luis, this is the first one, and the second one is San Francisco. So we're looking for the measure of variability for these two collections. Let's find the range first. The range of San Luis, we need to find the maximum value. The maximum value, it happens to be 79.8. Minus the minimum value, which is happened to be 29.9. The range of the temperatures in San Francisco, the maximum value is going to be just 62.3, and the minimum value is equal to, let us find it, 51.1. So we get 49.9. Very well. Okay, so let's do the subtraction here. We have 2.1 and 1. So the range of the data in the first collection is almost 50. Almost 50. And the range of the second collection is almost 11. So as you can see, the first range is larger than the second range. And you can say that, hey, since the first range is higher than the second range, it means that I have more variability in the first collection. So since the range of San Luis is larger than the range of San Francisco, so it is more varied. Okay, now next step, you're interested in finding 5-member summary for these two collections. Very well, let's list our data from smallest to largest. Remember that we are finding the median, so it's very important for you to write them in order first. The smallest value in the first collection is 29.9. After that, you have, let's see, we have 33.9. Then we have, let me see, 45.1. Oh, we have 33.9 again. We have 233.9. Okay, we have repetition here. We have 45.1. Then we have 46.2. Then we have, let's see, 56.7. Then we have a 58.4. We have 66.1. So let me write that a little bit closer. 29.9. 33.9. 45.1, 46.2, 56.7, 58.4, and after that we have 66.1, we have 75.4, we have 77.6 and 79.8. 79.8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Since we have 11 data, it means that the middle number is going to be your second quartile or your median. So 1, 2, 3, 4, 5, and this is the sixth number. This is the median or second quartile. Okay, the minimum value, the maximum value. Now, this second quartile, this median actually divides your data into two portions. The median of the first data is called the first quartile, and the median of the second portion is called the third quartile. Okay, 1, 2, 3, 4, 5. This one, this number here is going to be the median or the first quartile. And here, 75.4 is going to be the median or the third quartile. Let's find the 5-number summary for the second set as well. So our second set, the minimum value is 51.1, and then you have, let me see, 51.7. Then we have 54.4. Then we have 56. Yes. 56. Then we have 57.2. We have 56.6 as well. So let's add this, and also 56.6. And 57.2. Then we have 58.4. Then we have 59.1. Then we have 60.1. 60.1. Then we have 62 and 62.3. Very well. So this is your minimum. This is your maximum. The median, 1, 2, 3, 4, 5. This is your second quartile. The median of the first set is equal to, let me see, here you have median Q1, the first quartile, and the median of the second set is equal to 60.1, which is the median or the third quartile. Very well. So what we can do with these numbers, we can actually form something that we call a box plot. We can use 5 number summary to construct a box plot. Super easy to visualize a box plot. You have your minimum, you have your maximum. Your minimum is 29.9, your maximum is 79.8. Then your median. Your median is actually in the middle, and it's a little bit closer to, if you think about it, it's closer to the right-hand side. But again, this is going to be your median. Q2. And Q1, Q3, those forms the sides of a rectangle. So 33.9, it's going to be here. And then you have 75.4, which is here. So you connect these and you have a box plot, and you connect these two as well to get your box whiskers plot. This is Q1, Q2, Q3. So what does it tell us? It tells us actually our graph is a nice graph. It is actually showing that the data are clustered in the middle of the graph. So it's not skewed. We can form the box plot for the second data as well. So again, we need to find the minimum value, which is 51.1, then find the maximum value, which is equal to 62.3. So let us move this guy a little bit here. That's okay. So our Q2 is 57. It's exactly in the middle. So it's going to be here. This is your Q2. Then you have your Q1, which is 54. Then you have Q3, which is 60. It's going to be here. Now you are forming your box. The same as first box plot, there is no outlier in this collection. And as you can see, the data are all clustered in the middle. So let us calculate the standard deviation. You can Google any online calculator. For example, one of them is Alcula that you can use to find standard deviation. You can Google Alcula standard deviation, click on the first link. And here you can enter the data. So let us take the data from example here, I'm going to find the standard deviation for St. Louis. Here I'm entering all of these data, but note that you have to separate them by comma. So let us separate all of these by comma. And note that here you have a sample. It's not a population. So we select sample. Submit the data. Very well. So it says sample size is 12 and the standard deviation is 18. Standard deviation is 18. What's the meaning of that? It means that on average, each temperature is 18 degrees away from the mean. That's the meaning of that. Let us calculate the standard deviation for the second set. The best measure of variability is standard deviation. Okay, perfect. So let us submit the data. As you can see, the standard deviation for San Francisco is almost 4. What's the meaning of that? It means that on average, every temperature is away from the mean by 4 degrees. Again, standard deviation is much better than range or any other measure of variability.